This is using a reference angle to find a trigonometric function. Now the first thing you need to know before even knowing what a reference angle or a trigonometric function is, unless you don't know it already, is the unit circle, which is pretty much what it looks like as a Cartesian plane, but in essence it is basically a way to measure the degrees of any sort of triangle or circle on a graph per se. So basically how this works is if you start right here, the initial side I believe it's called, and you go around, you reach to the 90 degree, the 180, 270, and 360 again. So pretty much how this works is each sort of plane counts as 90 degrees. So in essence, if you go up here, you get 90, 180, and so on. And that is positive values of the unit circle. And now if you wanted to go negative, you would go clockwise instead of counterclockwise. Now you could go on infinitely with this. You could start at 0, you could go around, 3 times and get to 1080 degrees, or you could keep going, go to 1440, and so on. You could go around infinitely many times if you really wanted to. Which in a way, say for example we go around twice and we get to 720, which would end up right here on this axis, right? That would still be equal to 0 or negative 360, because in essence the value here when we reach 720 would be just the same as 0 or 360 and so on. For example, if we wanted to go here, we would go to 90 degrees, or we could go to 410 degrees. So basically what this is saying is that no matter how large the angle is, you can always find a reference angle. Say for example we want to just start off with some common reference angles. We have the sine of 45. 45 here is our reference angle. We also have the cosine of 30 and the tangent of 60. Now with the sine of 45, what you are pretty much measuring is where this degree angle is 45 degrees, what is the relationship between the opposite measurement side of a triangle and the hypotenuse side. Of course this is in a right triangle given it has a hypotenuse. So that value is root 2 over 2. So basically you're measuring, if this part of the Cartesian plane was cut in half, you would have this side right here. That's what the value of the relationship would be. The same could go with the cosine of 30, root 3 over 2. So in essence, when you have a 30 degree angle, which is very relatively small in comparison to larger angles, you will have a root 3 over 2 relationship between the adjacent side and the hypotenuse. And the same can be said for tangent of 60. 60 is larger than 45 and 30, obviously, so your relationship will be root 3, which means that the opposite side over the adjacent side will equal their relationship, or their ratio will be root 3 to each other. Now that you know that, we have to define what a reference angle is. A reference angle is basically, how I view it, a fake angle. Not necessarily that they are fake, but they can represent something and not truly be what they really are. For example, if you have 45 degrees here, you could use 135 to represent that, as you can see on this nice larger unit circle I made here. Here are some just general angles here. We have 45 degrees, and we also have 135 degrees. Technically speaking, 45 degrees can be used to determine the sine of 135 degrees. So if you were to, basically how you do this is you subtract this value, which is 180, as you can see right here, you subtract 135 from 180 and you get 45 degrees, which basically is your reference angle. The same can be done with 30 degrees. Say for example we just wanted to do this one right here. So for example, we went counterclockwise and went 150 degrees, but we were trying to find the reference angle for 150 degrees. We would do negative 180 minus negative 150, and we would get 30 degrees, or negative 30 degrees, which would then equal 30 degrees, just based off of how the unit circle works. And the same can be done for 60 degrees. Now these are your 3 reference angles that you'll be using. You can also use 0 and 90 if you really wanted to, and 180, but those aren't really necessary. The 3 are 45, 30, and 60. These are your common ones that you probably need to know. So in essence, you can also do 60. So let's say, for example, 120 degrees. 180 degrees minus 120 equals 60. The most important part to know about this is where your angle falls. So obviously angles here will be between 0 degrees and 90 degrees, but they'll never be 0 or 90. These here will be between 180 and 90, but never either of those either. These will be between 180 and 270, but neither of them, because if they fall on the axis, they are not on the plane technically. And these will be between 270 and 360. And you can also do the same for the opposite side as well. You can go from 0 to negative 90, negative 90 to 180, negative 180, negative 270, and negative 270 to negative 360. So that is how you find your reference angle. Now let's just determine these values. So the sine of 45, as we determined, root 2 over 2, cosine negative of 30 is root 3 over 2, and the tangent of 60 is root 3. So if you want to find a reference angle, such as, we'll say sine of 135, what we have to do first is determine which quadrant that is. Now thankfully I've drawn up this nice Cartesian plane as I showed earlier, and we can determine that right away. Where's 135? Well, if you didn't have this, what you'd have to do is basically say, well, this is 90, this is 180, it's obviously going to fall in between here somewhere. And since it is perfectly in between these two, it'll be 45 degree reference angle, or you could do 180 minus 135 and determine that that is 45 degree reference angle. So using that, the next thing you have to do is determine if the value is negative or positive in that said quadrant. So since it's in the second quadrant, we determined earlier that the sine and the cosecant are positive, and since we are dealing with the sine of 135, that would be positive. So the value that we will get is, and as you can see, that answer is root 2 over 2. Next, we'll be looking at the cosine of negative 150. Now, you can kind of see the answer. I kind of messed up earlier, so I had to erase it. Didn't feel like rewriting all of this, but yeah. So, here we go. If we're going negative, right, we're going clockwise, as we established earlier. So, we start here, here's 0, here's 90, here's 180. So, we're obviously going to be in the third quadrant, 1, 2, 3. So, if we have negative 150, which I've already drawn out right here, if we find the x-axis value, which this will be 180 or negative 180, if we subtract 150 from that, we'll get negative 30 degrees, which is pretty much equal to 30 degrees, given that they're both reference angles on, the same axis pretty much. So using that, our reference angle will be 30 degrees. But first we have to establish if this value will be negative or positive. Now we're doing the cosine of the third quadrant, which if you look, only the tangent and the cotangent are positive in said quadrant. So our end result value will be a negative cosine of 30 pretty much. So that will equal negative root 3 over 2. Now if you look, the angles are up here for these because, they're easier to know when you've already seen them. So the next that we'll be doing is the tangent of 120. Now let's look at our unit circle here again. As we see, you can go around the Cartesian plane so much, you'll get past the 90 degree because 120 is greater than 90, but here we stop. Now you may think it's 30 degrees, but it's not. Remember, it has to go along the x-axis. So technically speaking, you'll take 180 minus 120, you'll get 60 degrees, which will be your reference angle. Now next, since it's in the second quadrant, we have to determine if that quadrant has a negative or positive tangent value. So if we look in the second quadrant here, we see that only the sine and the cosecant are positive, not the tangent. Basically what we'll do is we'll take the tangent of 60, which equals root 3, and we'll have to make that negative. So our responding answer is negative root 3. So that's pretty much it. The most important thing to remember with this is your unit circle and your reference angles. Remember that you can only use reference angles with respect to the x-axis, not the y-axis. And remember your different quadrants and what their positive and negative values are. Also remember your reference angles and their corresponding sine, cosine, and tangent values. If you're doing the cosecant, the cotangent, or the secant, you can obviously flip those values, and if you have to, rationalize the denominator. So I think that's it. Yeah. Have a good day.